Good evening, GATE aspirants. Happy New Year. So now that we are 45 days or almost, I should say 30 or 35 days just before the examination, let me have a small talk with you. Irrespective of the result, whatever happens in your life, let me have that small talk with you. So here, as our subject is theory of machines and vibrations, so we will try to have the talk more relevance with our subject. So here we talk about two parameters. One of them is hope and another one is fear. So these two parameters are generated by a mechanism inside our body. So the mechanism which generates hope inside our body is actually manually powered, and the mechanism which generates fear is self-actuating mechanism. Now, one has to understand, in order to control these two parameters, what kind of input needs to be given to these two. The mechanism which generates hope needs to be accelerated, whatever the rate you prefer. And the mechanism which generates fear needs to be retarded. So here one must understand the balancing of hope and fear. How this balancing can be done? Let me give you the definition. The balancing is basically ability to reposition the pivot, and now you will not be successful in first or in multiple number of attempts. It is an endless process demanding you an unending effort. So with this small message, I try to consolidate whatever the message related to our subject, and begin the new year and this discussion of Score Booster series. And now I leave these points to you, and I leave the methodology or exploration of methodology to you, and begin the session. Welcome, dear students. So here we have the Score Booster series, which is including numerical answer type question and multiple select questions. So here in the question, the slider is moving outward on a rod with a velocity of 2 meters per second as shown in the figure. At the instant, the velocity of the slider is increasing at a rate of 6 meters per second. So velocity of the slider is increasing. That means the slider is accelerating. So direction of velocity is given as 2 meters per second, and the direction of acceleration is also 6 meters per second square. And the rod has the angular velocity of 3 radians per second in the counterclockwise sense, that is 3 radians per second, and the angular acceleration of 8 radians per second. So angular acceleration is also there for about 8 radians per second square. Now the absolute acceleration of the slider needs to be computed. So first is that here we need to mark the vectors associated with the acceleration. So vectors that are associated, the first one is radial acceleration, next is tangential acceleration. Along with that, you will have the linear acceleration of the slider, and there will be Coriolis acceleration. So to begin with, the radial acceleration will be here it is point A with respect to O, which is OA into omega square. So radial acceleration will be pointed towards left hand side, that is negative x-axis. So this the position of OA is 1 meter and omega is 3 radians per second, that is 3 square. And if we express this in the vector form, then it is minus I cap, it would be minus I cap it is. So this is minus 9 I cap. Next is the acceleration of the slider is outwards, that is 6 meter per second. Acceleration of slider I should be writing, that is 6 meter per second, and it is towards positive x-axis. So this would be 6 I cap. Next is tangential acceleration would be perpendicular to the link in the direction of alpha. So 8 radian per second, even that is in counterclockwise. So tangential acceleration of A with respect to O, which is OA into alpha. So OA is 1 and alpha is 8 radian per second. So this would be pointing upwards, so that is J cap. That is 8 J cap it would be. Next is Coriolis acceleration. So for Coriolis acceleration, we are finding the velocity direction, that is 2, and the direction of omega is like this in counterclockwise. So this needs to be rotated in the direction of omega, that is velocity v needs to be rotated in the direction of omega by 90 degrees. So this would be the direction of Coriolis acceleration. So Coriolis acceleration will be given by A superscript CR, which is equal to 2 into velocity of slider into omega it would be. 2 into velocity of slider is 2 meter per second. So 2 into 2 and omega would be equal to 3 it is. Okay. So this is equal to 12 plus this is 2 into 4 3 is 12 it is. 12 meter per second square. Now that we have tangential acceleration, Coriolis acceleration, radial acceleration, as well as the acceleration of slider is given. So resultant acceleration is obtained by summing up all these parameters. So let me check here, the angular acceleration is in clockwise. So I need to correct that this 8 radian per second is in opposite sense. Okay, let me correct that. So this is 8 radian per second and the unit vector has to be minus j cap. This is minus j cap. Okay, so now if we sum up all these vectors, that is radial acceleration plus tangential acceleration plus acceleration or linear acceleration of the slider. Next is acceleration, Coriolis acceleration. So this is minus 9 I cap plus 6 j cap minus of 8 j cap plus 12 j cap it would be. So I missed here writing unit vector. This is 12 j cap. So this would be 9 minus 6 is minus 3 I cap, and this is minus 8 plus 12 is plus 4 j cap. So resultant acceleration would be 3 square plus 4 square, which is equal to 5 meter per second square. Okay, so the answer for this question is 5 meter per second square. Okay, now moving to next question. So here it says the disk of radius 1 meter is rolling on the ground without slip as shown in the figure. At certain instant, the center of the disk is moving with a velocity of 10 meter per second. That is, velocity of the center of mass is equal to 10 meter per second, and the acceleration of the disk is 10 meter per second square. Okay, the magnitude of the point P, the magnitude of acceleration for the point P is exactly on the top, that is topmost point on the disk, instantaneously touching the ground. So sorry, here the point P is on the top. Okay, so now here at the point P you will be having radial acceleration. The point P there will be radial acceleration, and there will be tangential acceleration as well as the acceleration which is caused due to translation, which is also acceleration at the center of mass. So it is the vector summation of these three accelerations. Now to begin with, Now here you can calculate the radial acceleration. Radial acceleration is given by acceleration, let us say this is point P. Let us say this is point P with respect to, call it as O1. So acceleration of point P with respect to, radial acceleration of point P with respect to O1, that would be radial acceleration of point P, that is, just a minute, which is OP into omega square, and this would be minus j cap. So O is given as 1 meter and omega over here is going to be 10 radians per second because radius is 1 meter. So velocity at center of mass, which is also equal to r times of omega. So here this would be 10 square minus j cap. This is minus 100 j cap would be the radial acceleration. Next is the tangential acceleration of point P, which is still the same, that is 10 meter per second, which is OP into alpha. This is straight away equal to 10 meter per second square. This will be tangential acceleration. Now the vector will be I cap and acceleration of center of mass will be still 10 and the vector would be I cap. Okay. So now acceleration of point P will be vector summation of these values, that is radial acceleration of P plus tangential acceleration of P plus acceleration of center of mass, that is related to translation. So this is minus 100 I cap plus 10, that is 20 times of j cap it would be. So this will be, upon calculation, this you would be getting it as 100 square plus 20 square. So that is 10,400. So this will be a value which is slightly greater than 100. So you can approximate this to 100.1 or 01 meter per second square would be the value of acceleration. That is acceleration of the point P, that is topmost point on the circumference. Okay. So now moving to next question. So here it says about a cycloidal gear train shown in figure below. Gear 1 has 45 teeth. So gear 1 there is 45 teeth. Let me write the number of teeth as Z1, that is 45. And the the gear number 4, which is having 80 teeth, Z4 is equal to 80 teeth. And these two are the internal wheels. The pinion 2 has 15 teeth, that is Z2 is equal to 15 teeth. And Z3 is equal to 20 teeth. Okay. And are compounded. So here the gear 2 and 3, they are compounded. Okay. And are carried by the arm. The ratio of relative velocity of wheel 1 with respect to arm, that is omega 1 minus omega 5, to that of wheel 4 with respect to arm, that is omega 4 minus omega 5, is dash. So here the relationship between omega 1 and omega 4 and omega 5 is required to be expressed. Now let's see the diagram over here. So in the diagram you are finding that the number 1 is the internal wheel which is in mesh with 2, and 2 it is compounded with 3. 2 it is compounded with 3. So this will be 1, this will be 2, and 2 is compounded with 3, and 3 is in mesh with 4. 3 is in mesh with 4. So you could also observe that the size of 1 is smaller, that is 45 teeth, and the size of 4 is bigger, that has got 80 teeth. So now you could write the velocity or the train value expression, and after that you can derive the value, the ratio of this value. Okay, so train value is generally written as omega of output divided by omega of input. So now we take 4 as the output and 1 as the input. This would be omega 4 minus omega arm. You should be writing, you have to write it as relative velocity of 4 with respect to arm. Same way in the denominator it would be expressed as relative velocity of gear 1 with respect to arm. So that's when you subtract. This is equal to, now 1 is in mesh with 2. So here I can break down this into, let me write it over here. So omega 2 is the output and 1 is the input. So this becomes omega 2 minus omega arm divided by omega 1 minus omega arm into, next would be 2 is compounded with 3. So we could say that 2 is becoming the input and 3 is becoming the output. Although these two are compounded, you can say that both are having same velocities and this term is getting cancelled out. Now next is, you are going to take 3 as an input and 4 as the output. So omega 3 will become the input, that is omega 3 minus omega arm, and omega 4 minus omega arm it has to be. Now here this is how the train value expression could be written. You should be replacing the train value, that is ratio of velocities, with the number of teeth. So this will be replaced with the number of teeth. So this is going to be replaced with Z1 by Z2, as velocity and teeth are inversely related. And same way you can replace this with the number of teeth. This becomes Z3 by Z4. Z3 by Z4. As this is compounded, the middle term gets cancelled. So you will be getting the expression as omega 4 minus omega arm divided by omega 1 minus omega arm. So omega arm is basically omega 5, and this here we have got internal gearing between 1 and 2, internal gearing between 3 and 4 as well. So this is Z1 Z3 divided by Z2 Z4. So now substitute the values. Z1 is 45 and Z3 is 20 and Z2 is 15 and Z4 is 80. So this is 15 ones and 15 threes and 20 ones and 24s. So the answer would be 3 by 4, or which is 0.75 would be the ratio of omega 4 minus omega 5 divided by omega 1 minus omega 5. Okay, so for this question 0.5 is the answer, sorry 0.75. Now moving to next question. Yeah, so this is a question from the inverted pendulum supported with a spring as shown in figure. The undamped frequency of the resulting vibration. See here, many of the time the student struggles to understand the role of gravity. Most of the time the students struggle with the role of gravity. So as you check the options, you are finding the term g by 2 times of a minus g by 2a minus g by a, or k by m. So you should be understanding how the gravity is helping, because spring is the element which is mainly responsible for restoring to initial equilibrium position. That's the property of the spring, the elasticity. Okay, so gravity, there is no such definition for the gravity. Gravity could be helping for doing the restoration, or it could be against the restoration, or it could not be doing any of these things. It will be just as a spectator, neither helping the restoration nor going against the restoration. It will just be a spectator. Okay, so three roles are there for the gravity. So you should recognize by drawing the free body diagram that what is the role of the gravity in the given problem. So once you understand that, then you could pick up the equations very easily. Let's not try to solve the problem entirely. Let's first try to understand the role of gravity. Reason is that many of the students fail to understand or fail to include the gravitational effect in the natural frequency, or sometimes they also even ignore it. So one has to be very, very careful in deciding the role. Okay, so here, seeing this arrangement, I could say that mg is passing through the pivot. So when mg is passing through the pivot, the rod is going to sustain in this position until and unless if I don't disturb it, which means this is recognized as an equilibrium position. Now, what is that we do? We have to give some sort of initial disturbance. When you give the initial disturbance either to the left side or to the right side, doesn't matter. Let's say that you have given the disturbance to the left side, and you may see that the potential energy of this mass is getting decreased. Okay, it is going to be a lower one. And now here the mg will be acting over here, and as you have given theta like this. Okay, so now the terms which are going to, or the parameters which are going to resist the initial displacement or initial disturbance are inertia, that is associated with the change in state, that is I theta double dot, and along with that the spring is getting extended in the negative x direction, that is towards left hand side. So the spring force is going to restore or pull this back towards the right hand side. So this would be the role of spring force, that is Fs. So now it's clear that I theta double dot, that is inertial torque, and Fs both are in same sense about the hinge. And if you observe the theta direction, that is in counterclockwise, and you are also finding that mg is also producing counterclockwise movement about the hinge, which means the direction of mg and the direction of theta is same. Theta is nothing but the initial condition, initial disturbance. So mg is directed, or mg direction is favoring the disturbance, which means mg is not at all going to support restoration. It will be against the restoration. Okay, so that you have to understand. And if you are able to draw the free body diagram, starting with this, just give the initial displacement and try to examine how the mg is, what is the role of mg from the hinge point, and seeing the other parameters, that is internal resistances. One of them is inertial torque and another one is the restoring force. So you have to always check it. So mg is, from here mg is against the restoration. Now if you check the options, it could be either option D or option C. option A cannot be the answer and option B cannot be the answer, because here you are finding that G is positive sign. I mean, adjacent to G there is a positive sign. So this is telling you that Mg is supporting the restoration. So option B and A are out of the context. Okay. Now here first is that we need to write the equation of motion. So for that we need to take the moments about the hinge that is equal to 0. So I theta double dot, it is producing clockwise movement Fs. So here instead of writing Fs and then multiplying that with the perpendicular distance, you could write K into perpendicular distance from reference point whole square into theta. This you could write. Okay. Now reference point will be hinge in case of revolute joint. Reference point will be point of contact in case of higher pair. That you have to understand, because these will be including revolute joints or higher pairs. Based on that you can frame the equation. And the last term which I need to include is mg into perpendicular distance from the hinge up till the weight is L, or 2 times of A. 2 times of A, and the perpendicular distance would be 2A times of sine theta, which is also equal to 2A theta. So this is 2A theta is equal to 0. And from here you will be getting I as m into A square, or m into 2 times of A square plus K into A square minus mg into 2A, or 2mga theta is equal to 0. So now if you rearrange, okay, I missed here writing theta double dot. So theta double dot plus K by 4 times of m it would be, minus G by 2 times of A it is, into theta is equal to 0. This would be the expression for natural frequency. So please try to be very careful when you are trying to examine the role of gravity. Gravity can do the restoration, can be against the restoration, cannot do anything also. That understanding you have to develop. So when this gravity or mg is becoming a spectator, means not going against the restoration or doing the restoration, okay, when it is becoming the spectator, it will be trying to compress, or it will be trying to induce delta static in the spring. So there are few arrangements you can examine that. So whenever the delta static is being produced by the mg, their mg gets cancelled. That you have to understand. So as per the options, that is k by 4 times of m minus g by 2a under root, that is option D will be the answer. Okay. So please be careful. This was a question which was taken to help you understand the role of mg. Okay. Now moving to the next question. So here the question says about, at the resonance, which of the following statements are true? The first statement says that phase angle is 90 degrees. So at resonance, the value of R is equal to 1, and the phase angle is given by tan phi is equal to 2 times of zeta R by 1 minus R square it is. As R becomes equal to 1, then phi will be 90 degrees. Phi will be 90 degrees. Even if very small amount of damping, very small amount of damping, even if that is provided, the phase angle will be still 90 degrees. So statement the option A is correct. Okay. Next is option B says that transmissibility is greater than 1 for the damped system. So for this you should be knowing the transmissibility graph, that is epsilon versus R. So here in the graph, you will be finding this is epsilon equal to 1 and this is R equal to 1 and R equal to root 2. R equal to root 2. So this graph has got three different zones based on the frequency ratio or based on the ratio of frequency excitation. Okay, so first part, the graph will be closely following epsilon equal to 1 and then it reaches the peak value, and at root 2 it is going to decrease. Okay, so like that you can plot the graph for different values of zeta, but the transmissibility ratio, the transmissibility is always greater than 1 at the resonance, because at resonance the large amount of force is being imparted to the foundation. Okay, so at very smaller excitation frequencies you could say epsilon is equal to 1, and slightly after that in this zone you may find the transmissibility greater than 1, even that continues to behave the same even at resonance. And after R equal to root 2 onwards, you are finding the decreasing trend in the epsilon, that is when epsilon becomes less than 1, and that's when the isolation also happens. And this range where you find the graph is taking the peak value or more than 1, that zone is also referred as magnification zone. MZ, I am writing it. It means magnification zone. Okay. So statement B, it says transmissibility ratio is greater than 1. If it is damped system, it will be greater than 1. And if it is undamped system, then it becomes infinity. Okay. So next statement, it says that DMF is infinity for critically damped system. So DMF, the formula for DMF is given by DMF is equal to 1 by 1 minus R square plus 2 zeta R whole square raised to the power of 1 by 2. So zeta, here R is equal to 1. If you write it, the expression results as 1 by 2 times of zeta. If zeta equal to 1, then DMF will be equal to 0.5. It's not infinity. It's infinity for undamped system. So this is incorrect. This could be infinity for undamped system, not for critical damped. It's a finite value. And the second part of the statement says that vibration isolation occurs. No. Vibration isolation occurs after R equal to root 2, where epsilon is decreasing or below 0. In this zone, the isolation occurs. In this zone, the isolation occurs. Next is option D, says that transmissibility and DMF both will be attaining the peak values. Yes. At R equal to 1, if you try to examine the DMF versus R graph, even that graph also tells you the peak value. Okay. So statement A, B and D is correct. Understand that. So this was a question which I have tried to consolidate all the three graphs and important points of all the three graphs. So definitely you can expect a question from the graph, that is phase angle graph, transmissibility graph and DMF graph. Very, very important concept. Okay. Moving to next question. So here it says that car is traveling with a velocity of 100 kmph around a horizontal curve having a radius of 80 meters. So whenever you find a car question, and you find a keyword like spinning axis and normal forces and gyroscope. So just see no need to read the question thoroughly. Just see the keywords and try to find the relevance with those keywords so that you end up saving the time. Okay. So understand that keywords are also very, very important. So first here the velocity of the car is given as 100 kmph. And turning radius is 80 meters. each wheel has a mass of 16 kg. So mass of each wheel is 16 kg and radius of gyration, that's equal to 300 mm, which is 0.3 meters about its spinning axis, and the radius of the wheel is r is equal to, radius of the wheel is 400 mm. Okay. If the distance between the wheels, that is wheelbase, it's the wheelbase, that is B is equal to 1.3 meters, then the difference between normal forces of the rear wheels caused by the gyroscopic effect. So the normal forces you need to calculate. What are the normal forces exerted due to the gyroscopic effect? So first is that you need to calculate C, which is given by I times of omega into omega p, and here the linear velocity of the vehicle is given, that is 100 kmph. So omega can be calculated, velocity, that is v is equal to, okay, just a minute. So omega of the wheels is equal to velocity of the vehicle divided by the radius of the wheels. The radius of the wheels needs to be calculated. Okay. So now velocity will be 100 kmph, that is 100 into 1000 by 3600 into radius of the wheel is given as 400 mm, that is 0.4 it would be. This is the velocity of spin. This is the velocity of the spin. Okay, and velocity of precession, that I need to calculate. So velocity of precession will be V by R, that is wheel velocity is 100 into 1000 divided by 3600 into radius, turning radius is 80. Turning radius is 80. Okay. So now I need to substitute the values. C is I times of that is I is omega m times of k square, and omega is V by R times RW, that is radius of the wheels, and this is V by R, that is turning radius. So now substitute the values, that will be 16 into k is 0.3 square into velocity is 100 into 1000 by 3600 whole square into radius of the wheel is 0.4 into the velocity, the turning radius is 80. So this will give us the value of gyroscopic couple. You can calculate that. And next is they are asking the normal forces due to the gyroscopic couple. So normal forces can be expressed as F into V. So here it says the figure shows the curve for displacement, that is D, velocity V, acceleration A and jerk J versus angle of rotation of the cam during the rise of the cycloidal motion of translating follower. So here the curves are given to us, and out of these curves you are required to find out which is the correct one. Which is the correct one. So if you examine here, the displacement curve is going to talk about the rise. So the curve, I should say P, is a sinusoidal curve. It's not, it's going up and down. So P cannot be the displacement curve. Same way, Q is also a sinusoidal curve. Even that cannot be the displacement curve. Even S is also not the displacement curve. R, you can find it that it is rising. You can find R is rising. So R basically represents the displacement R represents the displacement. Okay, this is for cycloid. And next is, in the cycloidal motion, the velocity will be maximum at the center. So which curve is telling you about the maximum velocity at the center? That is, S curve over here tells you about the maximum velocity at the midpoint or at the angle when theta is equal to theta a by 2. Okay, so S is telling you about the velocity. That is, R is for the displacement. For velocity, that is, S is telling you the information about velocity. So RD SV it is. RD and SV, RD and SV. That is, either option A or B could be the answer. Next is, the cycloidal motion has the finite jerk at all the instances of the motion. Okay, so acceleration should not shoot up from 0 to maximum at one instant of time. At t equal to 0 instant, the acceleration should not shoot up from 0 to maximum. So now here, if I talk, the Q is another curve. The Q curve is a sinusoidal curve, and the other curve, which is P, you are finding that it is shooting the value at one instant of time. It is shooting from 0 to maximum and 0 to maximum. So this is what indicates the jerk is finite. Okay, this curve cannot be related to acceleration. If you say that this is related to acceleration, then at this instant of cam angle, and even at this instant of cam angle, there is going to be infinite jerk. For cycloidal motion, it does not happen. So this curve, that is P curve, is related with the jerk. That is, P is related with the jerk. So RD, that is, R is telling you about displacement, S is telling you about velocity, and P is telling you about displacement. Obviously, we are left with only another curve, that is Q, which is telling you about acceleration. So this will be Pj, Qa, that is, Q is giving you acceleration, R is giving you displacement, and S is giving you velocity. So option A is the answer for this question. Okay, so this was the question from the CAM and followers. Next question, pick up the correct statement among the following. First statement says that the flywheel controls the fluctuation of speed within the cycle. Next, governor controls the fluctuation of speed over a slope of cycles. Between two cycles, it says between two cycles, okay, between two consecutive cycles. So statement B is correct. Statement B is correct. Okay, and flywheel is a continuous operating device, and it has to control the speed fluctuation within that cycle itself. So option A is correct. Option A is correct. Next is, complete balancing requires the balancing of forces as well as the couples. Complete balancing means summation of unbalanced forces or summation of forces acting on the system has to be 0, and summation of couples produced due to rotation of masses also has to be 0. That's what we call dynamic balancing or complete balancing. Okay, so statement C is also correct. Next is, in the reciprocating engines, the primary forces can be balanced completely, whereas secondary are partially balanced. Reciprocating engines will be only partially balanced. Reason is that at the beginning of the balancing chapter, we find that the balancing is a process of either removing the unbalanced part or reducing it partially. In the definition itself, that has been indicated. So full balancing or complete balancing can be only done for rotating masses, whereas for the reciprocating masses, if we try to do that, then the direction of unbalanced force is modified, but the effect of unbalanced force or couple still continues to exert on the system. So in the reciprocating engine, we only opt for partial balancing, not complete. It has to be partial balancing. Okay, so statement D is incorrect. Next is, in a watt governor, the mass of the fly ball is 5 kg. Mass is equal to 5 kg. And effort of governor having equal arm lengths. Equal arm lengths means in that situation Q is equal to 1 for the 10% increase in speed. So C will be 10%, which is also 0.1. So what will be the effort when the speed has been increased by 10%? Okay, so now effort formula, that is E by 2 is equal to C times of small mg it would be. C times of small mg it would be. So this will be equal to 0.1 into mass is 5 kg and g is 10 meter per second square, and this will be equal to 5 into 10 is 50, 50 into 0.1 is 5 newtons. That is E by 2 is equal to 5 newtons. This would be the answer. Okay. Now moving to next question. Yeah. So this is about the flywheel fitted to an engine, maintains the speed between 8 radian per second to 12 radian per second. The turning moment diagram of the engine is shown in figure. Mass moment of inertia of the flywheel is dash. Now the turning moment diagram is approximately represented by 2 triangles. This is for some engine, and we are required to compute the moment of inertia of the flywheel. So here first is that we need to calculate the load torque. So now energy supplied or E supply will be equal to summation of these two areas. Summation of these two areas. That is, here this height is 200 and this is from 0 to 3 pi by 2. So 0 to 3 pi by 2 means it is 1.5 times of pi. So that is minus of 1 by 2 into height is 200 into 1.5 times of pi it is. This is the first area, and the second area it is half, base is 3 pi by 2 to 2 pi, that is 1.5 pi to 2 pi, which is 0.5 pi, which is 0.5 pi into height would be 600. Height would be 600. So this here we would be getting this as 2 ones and 2 hundreds, and this is 150 pi minus 150 pi, and this would be 600 by 4, which is 150. So this is plus 150 pi, which is equal to 0. So now E supply can be also equated to energy required, and that's when we get the load torque. That's when we get the load torque. Okay. So T load into cycle time, this is energy required. T load into cycle time, that is T load is not known, and cycle time, this is equal to 0. So cycle time here it is 2 pi, and from here we get T load is equal to 0. load torque will be zero. Zero resistance offered by to whatever the device this flywheel has been connected. Okay, and either of the areas is going to give you fluctuation in energy. As this is load torque line, so any one of the areas, either the top one or the bottom one, will be giving you delta Ke max, that is maximum fluctuation in kinetic energy. So now delta Ke max could be expressed as I into omega square times of Cs, or I should say here the range of velocity is given, so instead we would write that as omega max minus omega minimum square by 2 it would be. So Ke here it would be 1 by 2 into 0.5 into 600, that is 150 pi. This would be 150 pi is equal to, the value of I needs to be computed, is equal to omega max, which is 12 square, that's 144, minus 8 square is 64, divided by 2 it would be. Now if we calculate for I, that is I is equal to 152 into 2 is 300, 300 pi divided by 144 minus 64 is 80. So this is going to be 8 ones, 8 fours, 8 threes 24, and this is 8 threes 24, and this is 6. So approximately 8 by 30 means, yeah, let me try it with the 2 table. This would be 4 2s, and this is 4 7.5 is 30, and 2 1s, and this is 2 3.75 it would be. 3.75 into pi is somewhere closer to 12, somewhere closer to 12. So this will be approximately 11.78 kg meter square. So these were few questions from theory of machine which I have tried to cover in this session, and you can look forward for other questions and try to understand the question, or try to get the essence of question or what information that is being asked. So because there will always be a small hint that you should be trying to explore, and that's when you do multiple number of questions related to the same concept, and if you keep solving the unsolved questions, and that's when you develop it. So happy new year, dear aspirants, once again, and I would like to end the session with a very positive note. So as I begin with the hope and fear, so more or less we can find that balancing of hope and fear, we can relate those things, those parameters in multiple number of concepts what we have in this subject. Try to relate those two and then feel the subject. Thank you and all the best.